Hello, my name is Celia Merzbacher. I'm Executive Director of the Quantum Economic Development Consortium, and I'm pleased to be with you today. Thanks to D-Wave for organizing this event. Today's program is titled Developer and Researcher Day. And at first I thought that whoever came up with that title got it backward. We talk about R&D, or research and development. But when you say D and R, it really puts the focus on development and practical application, which is really what this conference is all about. D and R also implies collaboration. Developers need research results, and researchers are motivated to solve problems, including the practical real-world problems of developers. Today, I would like to talk about a number of what I think of as axes of collaboration that are being created and supported at QEDC, the consortium that I direct, to grow the quantum ecosystem. So I'll spend a little bit of time here at the beginning to define what I mean when I say quantum ecosystem or the quantum innovation ecosystem. Shown here are the different actors or stakeholders that are part of that ecosystem. They're sort of abbreviated, so I'll go through them briefly. In the middle, we have industry and government. At the top, I mentioned academia, university researchers, national laboratories, not-for-profit labs. An example of a not-for-profit lab is my employer, SRI International, which is a research institute that does work that's really sort of in between the level of readiness or the basic versus applied nature of research at universities, which is fairly basic, versus in industry where it's more applied. You have services, which includes organizations like intellectual property law firms, market analysts, and many others that are critical to the innovation process. We have educators of all kinds at community colleges, even at K through 12 education levels. There are venture capitalists and other private sector investors. And then I include standards developers, SDOs, who are really critical to the interoperability and setting standards and metrics for technology as it moves into commercial use. So all of these different stakeholders include others within them. And in the industry piece, in particular, in the quantum world, you have hardware developers and software developers. You have component suppliers. So you have the companies that are making and selling lasers and cryogenic systems and electronic controls and so on. And you have the end users who are pulling the technology forward by virtue of the interest they have in applying them to their problems. In the government sector, there also is a diversity of stakeholders. You think of the agencies that fund research and development, like the National Science Foundation and DARPA and the Department of Energy and others. But there also are government laboratories where innovative research is done for government missions. And then you have policymakers. I just list them here as represented by the Office of Science and Technology Policy. That's the office in the White House or the Executive Office of the President that includes the National Quantum Coordination Office, the US coordination office that coordinates quantum R&D across all of government. And then, of course, you have government regulators who play a critical role in determining export controls, intellectual property policies and regulations, IT and cybersecurity, and so on. So all of these different stakeholders are part of QEDC. QEDC is a consortium of stakeholders that was started by under the requirement of the National Quantum Initiative Act of 2018, which called for NIST to establish such a consortium. NIST selected SRI to administer the consortium. And so we're not a government agency, but we have funding from the government and from all the members. And we have a growing number of members today, more than 170 altogether. And I show the sort of breakdown in the top right here, mostly companies. And of those, more than half are small and medium-sized enterprises or startups, but we also have very large companies. We have universities, we have the government laboratories, the federally funded R&D centers, which includes the Department of Energy national labs like Oak Ridge and Brookhaven and others. We are expecting later this year to open a non-US membership, but today we're open to US-based organizations only. So this slide just sort of shows in one snapshot what QEDC's purpose is, its objectives and mission. The mission is easily stated. We are about enabling and growing a robust quantum industry. So we're very much driven by industry's needs and helping to address those needs. We have a number of objectives. We want to identify use cases and help understand the markets and when those are likely to be realized, and share that information very broadly so that investors, both in government and the private sector, can appreciate the potential of this technology and the timeline for its realization. But QEDC is really about helping to realize that future by identifying gaps and coming up with strategies for addressing them. So we do workshops where we look at enabling technologies and what are the needs in those areas. We have committees that are looking at standards and benchmarks and metrics. And in fact, we're going to be publishing very soon some results of work in those areas. We're not a standards development organization ourselves, but we do liaison with the standards developers and provide input and feedback as they develop standards in their organizations. We have a committee that's focused on workforce and understanding what workforce needs there are and helping to communicate those to the educators. And I'll speak a little bit more about that in a minute. And we really are in a position with our broad industry representation to provide input to policymakers that represents the broad views of all the different stakeholders in this ecosystem. We are about sharing that information, and we're more and more trying to communicate broadly about what the opportunities, what the use cases, and what the needs are so that they can be addressed going forward. And we facilitate connections. Really, an organization like a consortium, like our consortium, is really about connecting people, and I'll talk a little bit more about that since what we're really focused on here is collaboration. So I'll go through a number of examples of how QEDC is helping to stimulate collaboration, which I think is going to be critical to the success of the quantum industry. We, as I mentioned, have done a number of workshops looking in very great detail on the needs around different enabling technologies. This is just a little bit of a summary of the results of the workshop on cryogenic technologies for quantum information science and technology. We brought together, this was pre-COVID, we actually met in person and had about 60 experts. We spent a couple of days really picking their brains and working to drive towards a set of priority gaps. And I just show the ones that we highlighted in the report that came out of that. This report is, in fact, only available to members. We have a summary that we've put out, but a lot of the work that we do is really by and for the membership. And so to really get the full benefit of some of these activities, you do have to be a member. We are taking the results of that workshop, however, and launching a number of research projects later this fall to address some of these gaps. So that sort of is the full spectrum of activity, from identifying the gaps, bringing the community together to do that, and then taking the results of that effort and taking steps towards filling the gaps. The gaps can be filled by projects like the ones that we're doing. In some instances, a government agency may be more suited to addressing certain gaps, or perhaps the industry on its own will address certain gaps that have been identified. For instance, the fourth gap that's on this list, scalable, standardized cryogenics, speaks to the need for standardization. And that really takes companies coming together and deciding what they want to do in that area. Another type of collaboration is by connecting the members. And we've launched a new feature called Quantum Marketplace, which is a monthly webinar series where we showcase a handful of our members who work in a sort of similar space. Those are publicly available, and very soon we'll be posting on the public website the little spotlight videos by those member organizations. The idea being that we really want to raise awareness about the companies, many of which are small, and I just did a screenshot here of the our member website where we've already posted the webinars. And this is for Vescent Photonics presentation. So there's a little bit of information, and this will be also searchable so that we hope that it'll be easier to find these member companies and learn more about what their offerings are. Another a set of collaborations that I wanted to highlight are really focused on facilitating innovation. And so, for example, standards are really critical when it comes to innovating and ultimately commercializing technology. You really need to have interconnections, interoperability, compatibility, and that really takes the community, the ecosystem of industry coming together and setting those standards. And there are a number of international standards organizations today that are developing standards related to quantum information science and technologies. It's still rather early for some fields, but others it's a good time to start thinking about it. And we're certainly supporting that at QEDC, but you can learn more about it by doing a little bit of searching on some of the standards bodies that are out there. We also are interested in connecting members, our members, or companies that have a good sort of idea for developing a technology but need investment. And those investors may be in the public sector or the private sector. So I think this is going to be an area for finding opportunities for collaboration. And there are a number of new activities going on across the country at places like Duality at the Chicago area, the Quantum Startup Foundry in the Maryland, Washington, D.C. area. And these kinds of incubators for startups are going to be really useful in helping to fill the pipeline and take the results of the research and get it into practical applications. And third, we at QEDC have the opportunity, as I said, to provide input to policymakers. And an example of that is shown on the right, which is just an image of a bill that was introduced called the Quantum User Expansion for Science and Technology, or QUEST program. And that program was conceptualized by a group of QEDC companies that came together, competitors really in the quantum computing space, but together they developed an idea for a program whereby the government would put some funds into a pot of money that could be used to support researchers accessing commercially owned quantum computing resources through the cloud primarily, and eventually perhaps on premises at government facilities. But today, companies like IBM and others are making their quantum computers available online. And what we're hoping is that the government will be a sort of early adopter, in this case, by funding researchers to use those resources. They're improving rapidly. They are going to enable a lot of research to be done that the community hasn't had the sort of ability to perhaps imagine what they can do. So by making these resources readily available, by providing on-ramps to offer assistance to new users, we hope to greatly expand the variety of research. Could go out in directions like economics research or biomedical research and so on. So we really want to grow the pool of researchers, which will at the same time increase the number of people who have experience using quantum computers. And course, many of them may be students who then graduate and go to work for companies, whether they're end user companies or some of the developers themselves. So this concept is moving forward, and we're hoping very much to see it be appropriated and get started within the next year or so. Another way that collaboration happens is by connecting people, and students are of high interest to the QEGC member companies. They all are looking for talent, and there isn't a really robust pipeline of relevantly educated students today. So we have a feature, again, for our members where we have a database of students who are interested in opportunities in the field. And so we post some information about what their research area is, when they're expecting to graduate, and so on. So we're helping our members to find students who are interested and qualified. We have, I think, about 200 students in the database today. We also are trying to inform the university educators, as well as the students, about the workforce needs and what the opportunities look like. And about a year ago, we did a survey where we asked our members, what jobs do you expect to fill in the next 3 to 5 years? What skills do you want the people to fill those jobs to have? And what degree would you like them to have? So we got a very rich database, and we recently published a paper analyzing the results of that survey. And I encourage you to go and take a look at it. In summary, the findings of the survey were that, number one, there seems to be a steady demand for people in the quantum industry. There are a lot of different types of jobs, as you can see on the left-hand side. And the blue bar is sort of the 3 to 5 year hiring, and the brown or orange bar is the nearer term. So it's very strong over the next 5 years, and diverse, a lot of different positions. And those positions have a lot of different requirements that go with them, including degrees. And as you can see here, the purple is the number of people who responded that a bachelor's degree was the preferred degree for the particular position, versus green, the PhD is the preferred degree. And so depending on the position, the degree also varies. And many jobs, red is master's degree, many jobs, more than half, require a preferred degree of a bachelor's or a master's degree. So not everyone has to have a PhD to get into this field. And another finding was that you really just needed to get a little bit of quantum understanding to make yourself qualified for a career in this field. I won't go into details here. I don't have a whole lot of time, but this was a graphic from the paper that shows which skills, which important skills, and the definition of important was many companies mentioned it as a skill that they would be looking for. Which of those are quantum specific? And the blue ones are quantum specific, and the brown ones are not. So many of the skills that people are looking for are not quantum specific. So optics, photonics, and software skills are all important to hiring. So I'll just wrap up here in the last couple of minutes by making a few observations about the field, where we are. This is from last year. It's the Gartner Hype Cycle for Compute Infrastructure. And I highlight where quantum computing is on this curve. Many of you are probably familiar with the hype cycle. It goes from the innovation trigger, the beginning of an emergence of a technology at the left, goes through some peak of what they call inflated expectations or hype. And then there's inevitably a trough of disillusionment, after which hopefully you emerge through the slope of enlightenment to the plateau of productivity. And right now, quantum computing is up at the top. And the other thing that's interesting about this, and you can go read about the methodology they use, but quantum computing is the only technology on this curve that they label as being more than 10 years from application, I suppose, or commercial use. And so that's sort of interesting. It's high hype, but still a ways off, according to this analysis. I think what those of us in the industry hope is that we'll flatten the curve a little bit. We don't want the hype and expectations to be unsustainable, unable to be met. And we don't want the trough of disillusionment to be so deep and long that it kills a lot of the innovation that's going on. So that's a little bit of a cautionary picture. However, there's also this kind of trend, and this is data from the recent a number of deals and investor deals that have been made. And you see that there's a trend over the last several years of increasing number of deals, and even in the partial year of 2021, increasing dollars total among those deals. So I think the news is actually very good. I expect these numbers will continue to increase. And for those reasons, collaboration is going to continue to be important. And I think QEDC is poised to really help bring together all the stakeholders that are going to help to make quantum real and to bridge from the research to the developers. So thank you very much.
Hi again, Jen Houston here, and we're closing an incredible 2 days together. Stepping back and thinking about what I've seen and heard over the last couple days, there's a couple themes that have emerged for me. Number one is that quantum computing is here today. Yes, there's a lot ahead of us, but the amount of things that we can do now with quantum annealing is mind-blowing. The second thing that I was super excited was the concept of collaboration. The conversations, the sharing of best practices between people from around the globe. This is uniquely a time and a place and a technology for collaboration. And we heard that from PayPal, and I was really struck by Brian's comments on that. I think the third theme is, oh my goodness, there's so much going on. We have new technologies, we have a new roadmap, we have use cases all over the place. And I think that intersection of technology and passion and business value is really what makes qubits what qubits is. So I'm going to hearken back to the concept of relentlessly realistic. If you haven't yet had a chance to share with us your relentlessly realistic story, I encourage you to do it on social or on the existing platform. We want to hear from you about how you think about relentlessly realistic and what examples you have. But I'm going to go back to where we started this conference. Being relentlessly realistic means that we are at the intersection of great vision and incredible problem solving. And you must have both to do something as big as quantum computing. So I just want to thank you from everyone at D-Wave and all of our customers and partners. This has been a pleasure and an honor to spend this time together. Thank you. And I look forward to seeing you next year, hopefully in person.